a question or something. Okay, we're live.
We're live?
Yep, we're ready to go.
Okay. Hi, we're Dominic and Ham, and we're here at the University of Washington. We're from the Interactive Data Lab, which is the visualization group here at the university. And today we're going to talk about Vega-Lite, and give you a brief overview over this tool that we've developed in the, I guess, past year, year and a bit. You have this Etherpad, and in the Etherpad we also have a link to the slides, so you can follow along or later use them as a reference. But yeah, we'll just go through them with you, and yeah, let's get started. So who are we? I'm Dominic. This is Ham.
Yeah.
We're both third-year PhD students here in computer science, and we're working on data visualization tools, including Vega-Lite, but also other UI tools. And so yeah, we're just pretty excited to show this to you, and also want to hear from you. Who are you? Maybe, if that's possible, if we could just go around briefly, just get a quick sense of who's in the room and what kind of questions you maybe have for this tutorial. Is that possible, or should we do that over?
I think maybe we could all go into the Etherpad and say underneath Davis attendees, say who we are, and then put a little blurb afterwards. So I emailed out the Etherpad yesterday to everybody, and it's also linked on the Did Training page. And you can go under Davis attendees and then kind of put what your specialization is.
Yeah.
Hey, Dominic.
Hey.
So 3 of the people, half the room is my lab.
Oh, cool. Okay.
So we don't know what we do or what we're interested in, but we're definitely interested in visualization.
All right. Great. So hi, Titus.
Just sort of nodding.
Yeah.
Oh yeah, now the Etherpad is also filling with names. There were only 2 names in there before, so it's like 10-ish people or so.
Yeah, when people are trickling in, we're not alone.
Okay. Okay. Great. Yeah, I'll read the names in a second then. But yeah, let me just go and continue the presentation. Oops. All right. Yeah. So that's us here. For today, we want you to learn something. We want you to really understand what we know about visualization, what we've built with Vega-Lite, and how you can use it for your research, for your data explorations, and for maybe presenting results on the web. Please feel free to ask questions at any time. We really want this to be something where you learn something. It should be hands-on. We want you to also later follow along. We'll let you know at the time when we start the tutorial. But yeah, please ask questions at any time. If there's something that isn't really clear, then also feel free to just interrupt us via Hangouts. Otherwise, just put a question in the Etherpad. There should be a little section. This tutorial will roughly be till noon, and we'll have a quick break at I think 10:30,
Roughly.
Which is roughly an hour. So yeah, for this tutorial, we're going to go through I guess 2 main topics. One is effective visualization design. So we want you to know how you can create effective visualizations that convey your research results better. Or if you're doing data exploration, how you might craft visualizations so that you get the insights that help you further your research. And then we're going to show you how you can apply this knowledge with Vega-Lite, which is relatively closely modeled after these visualization principles. And yeah, so we're going to go through a tutorial where we're just going to show you how to create visualizations with Vega-Lite, and also how you can use Vega-Lite in Jupyter, so from Python. And then briefly, in the end, we're going to show you another UI tool which you can use to create the visualizations in Vega-Lite. Vega-Lite is coding, but you can also use a UI tool, which is not as full-featured, but it allows you to create visualizations more rapidly. And then we're going to briefly talk about some, like a little sneak peek of what's ahead with Vega-Lite and what we're working on here in the lab. So why would you create visualizations? Visualizations are really an effective tool to explore and communicate data. And often in data visualization, we try to keep those two things a little bit separate. Exploration is something where you might want to quickly create visualizations to understand data better. Whereas in communication, you might spend more time on a visualization. You want it to be tuned towards exactly what you want to talk about, and then you might want to put that in a paper or on the web. Why are visualizations great? Because visualizations are really, or the human visual system is really the most high bandwidth channel from the computer to the brain. So if you want to get a lot of data from the computer to the brain, then there's really no better way than visualization, because it's very effective and can process a lot of data in parallel, but also in the background. So there's a lot of subconscious processing happening that is not really happening in other channels. Yeah, and it's really a good tool when you want to augment the human capabilities. So if we have full automation, if we have a really good tool that does the job exactly as we want it to be, well, then there's no really need for visualization. We don't build visualizations to do math on computers now because, well, computers are really good at crunching numbers.
Yeah, but still, even if all the computer do the work for us, we still need some tool to understand what computer do, and
yeah,
a good way to understand data is using visualization to look at what the machine is doing. Suppose the machine can do the job.
Yeah. So if for example you have a machine learning model and you want to understand the parameters better, then visualizations can help. But it also can help in communication when you want to build trust in data. And to kind of illustrate this, oh, by the way, I have a few links here to some visualization classes. We also took some of the visualizations that are coming up from those slides, so definitely check them out if you're more interested in this. This is only a very brief summary of a week of classes. So why does visualization help? So here's an example. It's this data set here with it's actually 4 data sets. There's 1, 2, 3, and 4. And they both have 2 variables, x and y. And if you look at this data here, can you tell me what's like special about this? Maybe in the Etherpad, if you can just understand what is this data. What's interesting about this data is if you just run some statistics over it, for example, compute the mean, the variance, the mean of y, the variance of y, or the correlation between x and y, these numbers are actually all the same for all 4 datasets. So yeah, if you like, look at it for a bit and try to get a sense of what is this data.
Okay. So okay, that
show the same correlation. Yes, that's right. They have the same statistics. Yeah.
So what's wrong with this?
But what's wrong with this?
Can you guess?
All right, your brain isn't question get generated. Yeah. Well, let's plot them, and then it's immediately going to be obvious. Here are the plots. So the first data set is just there's a linear correlation with some noise. Then there's this curve here, which is not really linear. Then there's this one outlier, or all of them are at 8, and then there's this one outlier here with 19. But yeah, all of these have the same statistics, and it's kind of impressive that although they visually look very different, the statistics are the same. So kind of what we want to convey with this is often it makes sense to not just look at summary statistics, but really look at the raw data.
Yeah, and
to get a sense of what it's.
Yeah, and to be fair, from a statistician perspective, as you might argue that, hey, but if you use the right model, or for example, the top right one, if you try to fit with a quadratic model, it might fit better. But how do you know that, right? So visualization is a way to help you first explore the data and find the right model that you can fit. Otherwise, if you try to fit with linear model, for example, like what we just did, then you might fall into a trap that you use the wrong model for the data.
Mm-hmm. Okay, yeah, we just wanted to use this example to really illustrate this point. Okay, so when you create a visualization, Tamara Munzner developed these 3 questions that you should ask yourself when you're designing a visualization, and we're going to briefly go through them. And I hope that these questions can help you to design better visualizations. So these questions are what, why, and how. What do you want to show? Why would the user look at it? What is the task that they want to do? What do they want to achieve? And how is the data encoded? To answer the question what, usually we're going to have tabular data. Especially today in this tutorial, we're only going to talk about tabular data, where you have a number of fields or columns and rows, and at the intersection of these, so in each cell, is a value. There's obviously other types such as networks, but these are really not the focus today. In each of these cells, or sorry, for each column, there can be different data types. So if you think of this column, yeah, there can be different types. The 4 types that we're differentiating are quantitative, ordinal, nominal, and temporal. So let's look at this a little bit more. So these tables are just like a table in a database. Can be some measurements where, let's say, we have a few thousand measurements, which are the different items here, and the different fields are the measure. It can be the different fields. So let's say it's the measurement of a certain chemical, or a count, something like that. And these can have different types. When it's quantitative, we mean that it has a magnitude. So it's a number like 3, 7.5, 10, and so on. And you can really compare these numbers. You can say that one number is twice as big as another one. That's when we say a value, or sorry, a field is quantitative. Ordinal means there's some inherent order in the data. So for example, these T-shirt sizes, there's an order in them. So there's bigger, medium, and small. You cannot necessarily say that big is twice as big as small, but that's not important here. For ordinal, we only need an order. For nominal, this is the same as categorical. So we have data such as like red, green, blue. These are there's not really an inherent order in them. Or what are things like the weather, whether it's raining or whether it's sunny. These are nominal variables or categorical variables. And the last one is temporal, which is kind of a special case of quantitative, where we really have temporal data, and temporal data is special in the sense that, for example, years can wrap around. The months repeat within or after multiple years, and there's the same days in each week, and there's months have sometimes multiple weeks that are sometimes overlapping, sometimes not. So yeah, there's some special things that you can do with temporal data, which is why it's a different type.
Yeah, but in some sense, it's a special type of quantitative data that we impose some semantic that we use in daily life into it.
You could obviously think that there's obviously more data types, but for these 4 are really the most commonly used ones. Are there any questions about this? Because this is going to be critical for Vega-Lite as well. If there are questions, then just put them in the Etherpad, and Ham will answer them. So now we answered the question what. Now let's look at the why. And I think this is an important step when you're designing a visualization. Think about what you want to do with it. Do you want to visualize a trend? Do you want to show outliers, certain features? How might you pre-process the data? So earlier we saw with Anscombe's Quartet that looking at the raw data can be better than looking at summaries. But if you want to, let's say, communicate a finding in a paper, you might want to summarize the data a little bit to better show what you want to convey. Yeah, so always think about who's going to look at your visualization and what might they want to do with it. if you're doing data analysis, then that person is you. And now the, I guess, most exciting question: how do we do the visual encoding? So how do we represent the data? And typically in data visualization, what we do is we design a visual encoding, which is a mapping from the data fields, from the data, to some encoding channels, some visual encoding. And that visual encoding can be something like the color. So we encode a field from the data table here, one of these fields, so one column, with a color, or we can use the size, or we can encode it as a shape, we can encode it as position, and we're going to talk about all these things in the tutorial, what the encodings are. And so apart from this encoding that you have to design, you also have to think about, in the previous slide we said we should think about what is the task. Do we want to summarize it? And if we want to summarize, then we have to think about, is the summarization reducing the data by removing some of the rows, or is it taking multiple rows and putting them together by running an aggregation, so computing like a count or a sum over a certain number of fields. And we're going to show you these things in the tutorial, how you can do that with Vega-Lite. But you're probably familiar with some of these things from databases or just running filters and aggregates in Python. And another visual encoding is faceting. And what you do in faceting, so it's not here. In faceting is you partition the data by an ordinal variable. So here in this visualization, you see that we have a histogram over the horsepower, and we could have one histogram, but here in this case the histogram is split into three, where each histogram corresponds to a certain origin. So this is a data set about cars. I should have mentioned that. So data set about cars, and there's cars from Europe, cars from Japan, cars from the United States, and for each of them we now have a histogram. But separating these histograms in space allows us to compare across different categories, and that's called faceting. And we actually have native support for that in Vega-Lite to easier analyze categorical data. Okay, let's talk a little bit more about color. Color is a very common encoding, and actually when you encode data with color, you could encode it with the luminance, the saturation, or the hue. So luminance means like how bright it is. Is it like a dark color or a light color? Saturation means how saturated the color is. Is it like grayish or gray or actually full of the color? And hue means using different colors, so blue, red, purple, green, and so on. I talked about these different data types, the ordinal, the quantitative, the nominal, and the temporal data before. And typically what you want is you want to pick a color encoding that matches the data type. So luminance and saturation are typically used for ordinal or quantitative data, whereas hue would be used for data. And I guess intuitively that makes sense, but it's always good to put it down. One kind of exception to this is when you use two different hues, even for quantitative data, and that is something you could do when you have diverging data. So you have a 0 point, and then there's positive data and negative data, for example. Then often people use diverging color scales, where one color indicates positive, one color indicates negative, and then the saturation and luminance in this case together can indicate the magnitude of how positive or how negative some data is. But yeah, always think about, does it make sense for this data here? Is there a meaningful 0 point? If yes, then a diverging color scale might make sense. Okay, the slide is a little bit full, but here we have some kind of rules of thumb that are very, very useful to figure out what's a good visual encoding. And these 4 principles are consistency, importance ordering, expressiveness, and effectiveness. So let me go through them first. The first one is consistency. Here we mean that the properties of the image, so the visual variables, the encoding that we chose, should really match the properties of the data. What does it mean? So think of, for example, a map. All right, think of geographic data where you have longitude and latitude. In many cases, it makes sense to just encode it actually as the x and y position in the visualization. And only if you have a very strong reason for not doing that, then you should use a different encoding. But yeah, try to match the visual encoding to the data. Second principle is importance ordering. So certain channels are, so encoding channels like position, color, size. Some of these channels are more effective than other channels. And you should always think about what do I want to show in this visualization? What is the most important field? What is the most important dimension? And encode that with the most effective channel. And I'm going to talk about in a second about what is this ordering of channels. The third principle is expressiveness, and you could summarize it as tell the truth and nothing but the truth. What does it mean? In visualizations, you can add a lot of meaning by adding details to the visualization. So, like, let's say a trend line, or using some annotations, or just through the encoding itself. But you should always make sure that the visualization only shows things that are actually in the data. A very, I guess, prominent counterexample of this are node link diagrams. So these graph visualizations, often also called hairballs. Sometimes the algorithm itself causes certain artifacts in the visualization, which kind of make you think that there is something in data, but there actually isn't anything in the data. And that should be avoided. So this expressiveness principle tries to avoid that. And the last one is effectiveness, which means that you should use encodings that people can decode better. And that kind of goes along with this importance ordering here, where you should use the most effective encodings first. So here, I guess this rule is about the ordering of the encodings, whereas this one is about use only the most effective encodings. Don't use an ineffective encoding if you have a more effective encoding not yet used. Are there questions about this that we should maybe answer? Okay, if that's all clear, then let me show you, for example, another expressiveness example. So the first one that I talked, so this is this one here, the third rule. One example I already talked about was the graph. This is another one here where we have some quantitative data. So it really expresses a magnitude. So 78 is smaller than 99, and 153 is the biggest one. But if you encode this here with a shape, so let's say you encode 99.25 as a circle, this as a cross, and so on, then this is not a really expressive encoding. Yes, you could make some sense of it, but this data really communicates an order and a magnitude, whereas these shapes are only encode that the values are different. But that's not really what we want to show. So we're kind of, we're not very expressive. We're showing something that's not, we have a very misleading visualization here. That should be avoided. For effectiveness, so I said earlier, there's different different channels, and some channels are better than others. And the visualization community has done a lot of research to try to figure out what are the most effective encodings. And these are split by the different encoding channels. For all of them, I guess that's the most important thing here, the first row. For all of them, position is the most effective encoding. So if you only have and you have two position encoding channels. Usually you have X and Y. We usually not work in 3D, so only X and Y. And position is really the most effective encoding. So if you only want to show two variables, always use the position channels. Don't use color or length or all of these other encodings. Then for the second one, for quantitative data, so we have a magnitude. Length is the best encoding. So a bar chart encodes with length. For ordinal, so all of these here, the first ones are kind of colors. So for ordinal, it makes sense to use color. And same for ordinal, but same for nominal. But for nominal, the first one should really be the hue. So using different colors like blue, red, green. Whereas for ordinal, you want to use the different saturations or yeah. Okay, let's do a little game with this. I have two visualizations which encode the same three variables. So this is again this data set about cars. Your miles per gallon, horsepower, and that's actually the two that we have. Which of these two visualizations do you think is more effective? Maybe just put the answer 1 or 2, I guess, in the. Maybe we should just have a vote. Let's do 1, and then just put a left and right, and just put a I don't know, a tick or something after this when you think which visualization is more effective.
Yep.
Are people answering?
Not yet.
Okay. I still here. So yeah, I'll wait for I guess five answers for number.
Oh.
Okay, I guess we weren't super clear. So for the first, you shouldn't have posted one. For the first question, we have a few more. Yeah, exactly. Put an X there. Yep. Okay, so the right one, I guess, is what you think. Yeah, because it uses the length encoding instead of the color encoding for encoding the miles. Or sorry, the position encoding instead of color encoding for the miles per hour. Although the horsepower here is in both cases encoded through the position. So yeah, the right one is more effective, I guess. Now this one here, which one is better? For the first question, yeah, somebody says here, it also depends on what question you're trying to answer and what you need to complete. Yes, but for this first visualization, really, I cannot think of a case where you would want this left one.
Unless you have so limited space.
Unless you have very limited space, but let's ignore that for now. There's really, like in this case, there's really no reason to use the left one. I think similar for this one. I don't, unless you want to print it in black and white.
Someone say government contracting, of course.
Government contract? I don't understand that answer. Oh. Okay, if you want to deceive with data, there's a really cool paper actually about how to best lie with data.
Actually, a book.
Well, that's lie with statistics.
Yeah.
There's lie with statistics, but there's also how to lie with data. That was a paper.
I see.
And they explore some techniques to, best deceive with data. Anyway, yeah, so for this one here, the left one is clearly better because it uses for an ordinal variable, which is the origin here. That's the only difference. For the origin, it uses a color encoding rather than a shape encoding. And it makes it much easier to see that, well, cars from the United States have higher horsepower and fewer miles per gallon, whereas cars from Japan and Europe are more up here in the upper left, which is impossible to see in this visualization. I guess if you look very carefully, but it's almost impossible to see. Okay, so the left one is better. Now the last one. Here again, we're encoding the same variables. So yeah, if you want to answer for the third one, just put your X's there. If you want to vote for both, go ahead. Okay. Yeah, it looks like people are voting for both, and I think in this case, it's really not clear with just a better visualization, because they show different aspects of the data. So if you want to focus on really the horsepower versus miles per gallon, then this is the better visualization. If you want to show how do the miles per gallon differ in different depending on the origin here, then this might be a better visualization. You could even say that you want to do an aggregation here to compute the mean. But yeah, really, this is usually then this might be the better visual encoding. Yeah. So it kind of depends on the task, and yeah, you can say it. Yeah. Okay. Yeah. But if we don't know the task, we might argue that the right one is better, because it uses the yeah, it's kind of hard to see here what the different where the different points are, and the more effective channels are the length encoding. We use them for the fields which I guess are harder to differentiate. So for origins, we only have these 3 origins. So using the length encoding here is kind of a little bit like a less effective encoding.
Yeah,
anyway,
if you don't know what to focus.
If you really don't know what the task is, then you might prefer the right one. But otherwise, I think, yeah, it really depends on the task. Okay, so after this little primer, this was, by the way, a week of visualization class. So if you have any questions, please let us know. Now let's talk more about about visualizations and how to create them. There's a bunch of things involved or a bunch of terms around visualizations, and try to summarize them a little bit on the slide here. So this is here the chart, which has the main chart and the legend. We call these bars, or whatever you use, we call them marks. So here on the previous slide, the circles were the marks. Here the bars are the mark. Oh, you don't see my cursor. Oh yeah, actually. Oh, you do. I might. So yeah, the bars are the mark. This chart has 2 axes. This variety axis and this down here with the yield. These the numbers here and these the text here, we call them axis labels. This down here is the axis title. These are the axis ticks. So this one has 1, 2, 3, 4, 5 ticks. The legend also has a title, legend title, legend labels, and legends and axes. Together, as a group, we call them guides.
So what is a legend?
Legends.
Yeah, explain what's. So basically, if you are not familiar with what legend means, so basically, legend here try to guide you to know how non-positional encoding represent data. Like here, different color represent different value. Like blue here is Crookston, and orange here is Duluth. And you can create similar legend for when you use shape or you use size to represent data too.
Yeah. We just want to go through these terms because you're going to use exactly these terms later to customize the visualizations in Vega-Lite. Some things that are not shown here are the data, the underlying data, and the transformations that are being applied. So here in this case, there's some aggregation going on and stacking. The different encoding channels, So X, Y, color, size, and some more. We talked about them before. The encoding is the term for this mapping from fields to channels. And that's also what you're going to have to specify when you create a visualization in Vega-Lite. And the last one is, the last term is a scale. What are scales? Scales are the mapping from the domain, so from the data domain to the pixel space or the colors. Let me show you. Like there's kind of two types of scales. Typically, we have scales that map from the data domain to the pixel range. So if your data is has the magnitude of 20 to 80, then you might want to map that to something in the pixel space of the visualization. So the 0 and 120 here could be from here to here. So here the domain is 0 to, what is it, like 400 something-ish. But we want to map it to the pixels that start here and end here. I don't know how many pixels those are here. There's also scales for colors, where you map from data domain to some color. And that can either be just the hue or the saturation or the value. In Vega-Lite, we have defaults for pretty much all of these things, except for mark type and the encoding. So whether you want to use a bar, point, or so on, you have to specify that. And you also have to specify the encoding, so the mapping from fields to channels. But everything else we have defaults for, but you can specify them if you want to customize them. Okay, I think with that we're through the visualization design. If there are any questions, please ask them now. Otherwise, we'll go on, or Hem will start with the Vega-Lite tutorial. And while we're waiting, you can open this URL. We also have it in the Etherpad. Please let us know if there are any problems with opening this editor. Okay, then let's switch seats here.
Okay, so that
I'll keep monitoring the Etherpad, so ask questions.
Yeah, so that's a lot of the introduction to theory. It's like a quick run through the theory about like how to design visualization. So now we're gonna introduce our Vega-Lite 2. So let's start with what is Vega-Lite. So it's a visualization specification language. So we use JSON syntax for that enable you to rapidly create visualization, mostly for analysis. But basically, the reason we use JSON file is that Vega-Lite can serve as a file format for creating and also sharing visualization. So in the Vega-Lite spec, it basically describes component of visualization like Dominic described before. It can describe data source. It describes transformation, which is optional. It describes the graphical mark type like bar or point or line or area. And it describes the mapping between data and encoding channel, which we call encoding, and also support properties of scale, access, and legend, and fasting. You see more examples. So this is like overview. And if you're not familiar with what is JSON, so basically it's a text-based data interchange format based on JavaScript object. So here's it look like. So basically you use curly braces to describe object, and object can have different type of properties. You use string to describe the property name, and then there could be variety of property like number, string, date. It can be an array, or it can even be a nested object inside the JSON. And we use this syntax to describe visualization.
Yeah. One thing here, date is not really a type that's supported in JSON itself. It's just a string, so that's why strings always have to be put in quotes.
Yeah, but in Vega-Lite we deal with the date.
We can automatically parse it, but it's just a string in JSON itself.
Yeah, I think in JSON they support some data type too, but it's not as string. Some GMP they have that, but anyway, it's not a big point here. So if you haven't, like, now we're gonna try to walk you through some example of how to create visualization in Vega-Lite. So please open the Vega editor and try to follow along. So now I'm gonna try to split the screen and okay, it's telling me to update my computer. Definitely not now. Okay, so in today we will split the tutorial into two parts. So first, let's begin with some hypothetical data. Like, let's say we have a tabular data like this. It has two fields, or we might call it variable, but in Vega-Lite terminology, we call it field. And A is a categorical variable with three categories, C, D, E, and B is a quantitative field or variable, C number 274. So this is a table, and in JavaScript and in Vega-Lite, you can represent the data in JSON like this. So basically, there are different objects for each item, and for each object, we represent the column name with the key, and here C is the value, and another column is B, and then the first row has value of 2. So this is how we can represent a data in JSON. So how do we describe data in Vega-Lite? So basically, we use JSON. So we can describe data in line with data values. So in the Etherpad, we have the data here for you. So you can copy this data into Vega editor, and
can make it bigger.
Yeah, let's make it bigger. Okay, let's make it. Okay, this should be enough. And
if you cannot read it, let us know.
Sorry. Yeah, so an array, this is not Vega-Lite. So when we say describe data in line with data value, this is what we mean. We have data at the top level, and then value here. The value of values is the array, the data array. So here is how we describe data in line. You can also describe data via URL, which we will describe later. We will show you later in the latter part of the tutorial. But let's stay with inline data for now. Oh, just note that here you might see that the data is like 9 items. We just save space and wrap them into 3 lines, but it's the same JSON object. Okay, that's the data, but we haven't tell the tool how to visualize it. So another property is mark. So here we're gonna start with some simple mark like a point, and here we can say okay, point, and if we click parse, then we see a point or circular point. Yeah, but
let's wait for them to do that. So yeah, let's if you could all write this and just see whether that works for you. If there's any problems, maybe ask a neighbor. When you do a mistake, like when you make a mistake like forgetting a comma, for example, you will usually get some help about the JSON syntax. But there's not too much error correction here. The only thing that it tells you is if your JSON is completely invalid. What might help is also formatting. If you want to see whether your JSON is valid or what the nesting is exactly. But yeah, try to write this and let us know if it doesn't work. Also, feel free to just paste it in the Etherpad if it doesn't work, and then I can try to debug it. But if there's nothing, we'll just continue.
Yeah. So now we have a point, but we haven't tell the tool how to map the field A and field B to properties of the mark. So here, although you may seem to see just 1 point, it's actually 9 points and stacked on top of each other, so it's pretty much occluding each other. So let's try to map variable to map the field to the visualization to the channel or property of the visualization. So the next part that we're going to write is encoding. So here, encoding as a property, and it's an object, and we can describe the mapping between channel like X to the field, like map A to X channel. I write field A.
Can you zoom in a little bit more?
Someone cannot see?
Jessica said, yeah.
Okay. This is tricky because, okay, this is the maximum we can get because we cannot resize. Yeah. Okay. Okay. But here we also need to tell the tool what type of data it is. And here it's nominal data. Okay, so say this, if I click parse, then you start to see something more interesting than just 1 point. So here you see an axis with C, D, E, and 3 points. Or actually 9 points, but they are still occluding each other. If you see from the data value here, there are 3 points with C's and 3 points with D and E. So next, if you want to create a scatter plot of this, obviously we would want to map B to Y. So how about this? How about think about how would you do that? It should be pretty straightforward, and in a minute I'll show you how to do it.
Okay, so again, the task is now to create a scatter plot where you map A to X and B to Y. We'll give you, let's say, a minute, and then, or yeah, let's say 30 seconds is fine. And then maybe if you have it, maybe you can just post your spec in the Etherpad so that we know that you're done. Perfect. All right. So yeah.
Yeah.
Okay. Then Ham can write as well.
Yeah. So basically, then again, you map Y and you say field, and field is here B, and the type here, because it's a quantitative data.
Yeah. So one thing here, if you could also treat the field B as an ordinal or a nominal, but in this case, Vega-Lite would show you a different visualization. So maybe Ham can just demonstrate that.
Yeah, it will look slightly different. So what's different here is that when you apply to ordinal, then we don't care about quantity. We just think it's as like a a category with order basically. And if you look at the data here, there's no 3 or 5 or 9. That's why the scale only show 1, 2, 4, 6, 7, 8. Yeah, but we want it to be quantitative. We want to preserve its linearity. That's why we use quantitative. And here you see a part of the scale and axis for 5, although there's no explicit value for 5. Okay, so this is a raw plot. What if we want to create a this is that. So in the slide we also show most of the solution, but yeah, it's for the reference later. So what if we want to aggregate? What we can do, like here, is actually we can write another property called aggregate. Definition. This part, aggregate means seeing 9 points, you only see 3 points because here we calculate the mean of B grouped by the field A, and here is the average value for each group of A. So in other words, if you're familiar with SQL, this is the same spec and visualization. This is data query equivalent to select mean B and A and group by A in SQL. So, and obviously we do more because we map this to graphics. Yeah, but the data part, this is what it's basically saying.
And just if you're familiar with SQL, in SQL you always have to specify the group by. In Vega-Lite you don't have to do that. So everything that is not aggregated is automatically grouped by.
Yes, if I understand correctly, some variant of SQL you don't need to do the group by too, right?
No, you don't. But
yeah,
I think in SQL you do.
Yeah, in some variant, but yeah, that's not the standard. And yeah, you can try to do other kind of aggregation, like max or min or median, something like that. So you get the idea. There are different aggregation function, and you can look at the documentation for list of possible aggregation. And then this is a point, right? This is a point. So what if you want to make it a bar? So do you want to guess how do you want to how can you modify this into a bar chart? So any answer? Yeah. Okay, it seems quiet, but it's actually pretty straightforward. So what you need to do is, so now we say the mark type of the graphic is point. If we change it to bar, then here's a bar chart. So yeah, and there are the other type of graphics too. Like if we change it to line, then you get a line chart. You can change it to area, and this is an area chart. So yeah, so you can change the mark too. Okay, and this is pretty much repeating the same thing. So the next question is, what if you want to transpose? Like we want to flip x and y axis, like changing a to y and x to y, b to y, average b to y. How would you do that? So let's say I give you 30 seconds, and again, if you finish doing it, you can paste the answer. So now I change it back to bar. And how would you swap x and y, or in other words, transpose?
I do also config.
We can add.
We should try that documentation. Yep.
Okay. Yes. So basically, yeah. So basically, you just swap x and y here, and basically now the field A is mapped to y, and field B, which is also aggregated by mean function, is mapped to x. And here is how you get a transpose. Yeah, and this is the answer. You can also customize different aspects of the visualization. For example, here we're gonna set the title of axis to average of B. Like here, you can see that we automatically generate axis title from the definition. Like here, the field is the B, and we mean, so we write a function form for the title. But we can add axis.title here. So I add property axis, and then it's a nested object, and say, and then I parse. So we get average of B here, or we can say like our workshop. Then we get weird axis title, but you get the idea. You can customize the axis title here. And you can also customize the size of the visualization in a part of config. And one part of Vega-Lite is that we call the single visualization itself. So to customize the size, we have to say the cell, and then we can say width, and then we can say let's say 500. Yeah. So now it's become bigger than my screen. So that's not a good idea. So maybe I'll make it smaller. Yeah. You can also set the same thing for height too. Like here, height is probably only 100. So let's say we can say set height to. Oh, so that's one thing that so okay, I forgot.
Well, you can transpose, then it works. Transpose.
Yeah, if you then it works. The reason being that for quantitative scale, like here, you can set the height directly, but for ordinal or nominal scale, we actually scale the size of the visualization based on a property called bandwidth. So I actually forget to mention about that. So here, to set the bandwidth of the bar to be bigger, you can say scale. Actually, and say if I want the band size to be bigger, then I say band size 40, and it's bigger. If I make it small, it's smaller. Yeah. So here's the part that that Dominic explained earlier about what is the scale and how do you map the raw value into visual properties. And in Vega-Lite, normally you don't have to worry about manually creating scale. Like if you use other tools like D3 or Vega, you have to create scale manually, or you have to create axis manually. Here we automatically create this for you, but if you want to customize the properties, then you can customize them as a part of the spec. So the more details about this are in the documentation, but this is like to give an idea that you can do this kind of things. Yeah, so you can customize. And another thing that you can do, so this is like just playing in Vega editor, right? But oftentimes when you create a visualization, you want to publish to a website. So we actually create an example page here. So this is a very dumb page for publishing Vega-Lite visualization. And as we put it here, there's a link to the code on GitHub. And apologies for making it a little ugly because we want the code to be minimized. I haven't put any CSS style here because I want to be like extremely lean. So here's a code on GitHub. It's github.com/Vega/Vega-Lite demo. And basically, this is the HTML page that we publish here. And we use GitHub pages to publish this. So actually, if you want to paste your own visualization, you can easily fork. Like this is on Vega organization. I can fork and put it to my account. Okay, wait a few seconds, and GitHub will create a fork for me. And here's my fork. And if you look at the URL, here's vega.github.io. If you have your own account like mine, here is my account. I can I guess we have to wait for a few seconds. Let's see the setting, and it doesn't detect my GitHub pages branch yet somehow.
I guess it's just slow, but it will come up.
Yeah, it will come up. So let's come back to this later after the break. So GitHub usually takes a few minutes to set up the page. So basically, we have the template for publishing Vega-Lite specification here, and if you go to GitHub and look at the code, this is what you need to do. Basically, you import the script, and Vega-Lite require other two libraries called D3 and then Vega and Vega-Lite itself. And here we use a library that makes rendering Vega-Lite easier called Vega Embed. And here I just say the H1, the text template you see. Basically, this is the main part. The main part is you create a div for containing as a container for the visualization, and you paste the Vega-Lite specification here. So you see this is the JSON part that we will show you in the tutorial before, and that is this part that you say is a it's a metadata part for Vega embed. And here we say the mode is Vega-Lite, and we put the Vega spec up here, in here. And there are always other properties for configuring Vega embed. We're not going to cover that for now. And you call Vega embed and pass the embed spec, and that's pretty much it. To get the page running. So now it's an hour. So after the break, we'll take you through a second part of the tutorial, which try to explore more real data. So like we have shown you a hypothetical data and show how you can create visualization with Vega-Lite. We're gonna have another data set after the break. So,
yeah, but maybe to give you just a sense of what we talked about. Don't worry too much about this, the GitHub and forking and the website that we just showed. But as you can see, there's only very little code you have to write to embed a Vega-Lite visualization, and I hope we got that point across. For Vega-Lite, we hope that you see that it's very easy to create common visualizations with just a few lines of code, and especially for data exploration, we hope that this will be useful, because then you want to rapidly look through a number of visualizations to look at your data from different angles, and so we will do that in the next tutorial. Look at data from different angles using Vega-Lite, and the visualizations that we will build there will also just be a few lines. Yeah. So if there's, I guess we'll have a break for like 10 minutes, so we'll come back at 10:35.
Yeah, if you have questions, feel free to leave them on the Etherpad. And
yeah, I guess I'll also stick around in the Hangout. So if you want to just come up to the Hangout, then we can also do that. Otherwise, we'll see you at 35. I mean, we still have 1 hour, so.
Yeah. Okay, so we are pretty much back. So are people back here yet?
Yeah, just give us a hands if you're back, or post something in the Etherpad if you're back.
We'll probably.
Pardon?
We will.
You're breaking up, Jessica.
Hello. Okay.
Okay, 1 minute.
1 minute. Yeah. For people who are back, yeah, there's a website, like our website, vega.github.io/Vega-Lite, and there are lots more examples than we can show today, you know, and there are documentation about. Yeah. Like just while you're waiting for people, like there are documentation examples, you know. Anyway, so we'll go through this and show you more a bit examples at the end.
Do you have the supplemental material? Sneak peek. You have it ready?
Okay, so people are back. Okay, so now it's the second part of the tutorial. So now we try to walk you through how to explore data with Vega-Lite. And the data we're going to explore now is a weather data set for Seattle. And it contains actually 6 fields. One is the date, and it's date ranging. It's everyday data from 2012 to 15, and it contains data of precipitation in centimeters and max temperature and minimum temperature in Celsius, and wind for each day, and type of weather for that day. So it's a categorical variable like drizzle and rain.
Because that's all we have.
No.
We have some more. We also have like sunshine, but we'll look at that.
Yeah. So here, unlike the first tutorial that we use data inline, so here we're gonna import data from URL, and I believe we have the template here in the Etherpad, like here. So we can copy that to the editor, and hopefully this is big enough. Let me. Do I do something? Oh, but because it doesn't have anything yet, that's also if it doesn't respond to when you only say like data. Okay, so now it's refreshing. So what people typically do when they're first exploring data is to examine each variable with either dot plot or histogram. And here is how you can create a dot plot. So basically, you can use map like point, and here we map on horizontal dot, map a field to x. And the first field we're gonna create a dot plot.
Go ahead.
And okay, so
Yeah, nobody can hear you while you're typing. Nobody can hear you.
Okay, that's good to know. Again, so I create map x to precipitation and set it to type quantitative. So I get like a dot plot that's the distribution of precipitation. But you can see that if you use point or circular point here, there are a lot of occlusion. Maybe using tick mark, which is sort of similar but take less space horizontally, you can see the distribution a bit better. So basically, yeah, most of they don't have that much precipitation. Only rare case when there are a lot of precipitation, which is pretty much true because the rain here is not that hard. Like I I grew up in Bangkok, and the rain in Bangkok is actually much more harsh. Yeah, so that's one way to like see like univariate distribution of a variable. Another way is to create a histogram. So what is a histogram though? So histogram actually try to group data into different to a uniform bin. So for example, here we can apply a bin property like bin. So now the data is sort of grouped into bin, but it's going to look weird with tick. So maybe if we change it to bar. So now we still don't get much information from this plot, because now we know that there are data in all the bins we have from 0 to 10, from 10 to 20, 20 to 30, and so on. But what we can do is we can count the number of value in each bin. We can set just like in SQL, when you count, it doesn't matter which field you count. We can asterisk.
I think there's some problems with the audio. Let's try something. Let's try to get the audio from my computer, and then you can type on your computer and get the audio from this.
And how do I
just turn off this mute microphone?
Would that work though if someone's typing?
Okay. Oops. Okay. You should be able to hear us now over, like from me, but you should see Ham's computer, and that way he can type while you can still hear him. Let us know if this works, please.
Yeah. Okay. So if you now I add count.
Microphone's here. Okay. Good. Go ahead.
Awesome. So if we add count here, then you see that, yeah, as we shown before with a dot plot, a lot of days has low number of precipitation, and yeah, and it's going so on and on. Is pretty low. Actually, if you want to use different type of scale, like log scale, you can customize the Y and say scale, and say type, and say log. And I think I added
format this.
Huh? What?
Yeah, format this a little bit better.
Okay, I think I make a typo. Okay, let's try linear first.
So someone here has a question.
Can you copy it?
Can you?
Log should work, yeah.
Okay, maybe we have some bug. I'm not sure. Yeah, but ideally this should work. I don't know why it's not working now. Maybe I'll try to fix this and send email to people later to show how it works. But basically, okay, now you can make a histogram. So what you can do now.
Okay, perfect. It's all good.
So what we can do now is try to examine other variables. Like as said, like there are 5 other variables. So why don't you try to create dot plot or histogram, whichever you like, for temperature max, temperature min, wind, weather, and date, and paste your spec in the Etherpad. Yeah, and I just realized I forget to show you how to make GitHub forking works, but I will show that at the end. If I forgot to do so, remind me. Yeah. Okay, so let's say we give you a minute and you try to create some other dot plot and histogram and paste the spec, and I can walk you through the same process.
There was this question whether you muted Davis. I think you are muted. I think the only person that's not muted is us here.
2 people.
Can you hear us here? No? No, they can't.
Can you hear us?
Yeah.
Okay, they can hear us.
No. Okay, so. Okay, sorry about that.
Someone says that looks like you can save some typing by shortening name quantitative to Q. Yes, exactly. But we don't do that now because we want to make it clear that quantitative is Q is quantitative. Yeah, but yes, you can be lazy and shorten. What other shortcuts are there? So the only thing that we provide shortcut now is the type. So you can say type O is ordinal, type N
Yeah, N is nominal, T is temporal.
Yeah, and that's
Q is quantive.
Yeah, and that's the only shortcut we provide there. Yeah. Okay, so let's walk you through this process together. So let's say I create histogram for temp max. So basically, it's easy. We have the template. So we just change the field to temp max here, and you get the histogram. Maybe I should resize the window a bit. Same for temp min. Okay, maybe we would want to take a look at the distribution a bit. This looks a bit Gaussian, I guess, but yeah, not exactly, but pretty close. Temp min. Interesting. Oh, there are some very cold days which minimum temperature is minus, so that's why the axis shift a bit. And what other variables we have to look at? Okay, wind and wind. Okay, so most of the time it's not too windy. Yeah, but there are some higher, say. Yeah, this kind of data would be more interesting to compare with other city too. But yeah, for simplification, this workshop, the data is pretty simple. And weather. And weather is a categorical or a nominal variable. But you should not bin the weather. That's why.
Yeah. So binning, basically what it does is it kind of converts your quantitative data to ordinal data, as I said earlier. And so if it's already nominal, well, then you cannot convert it. So you can only apply binning to quantitative data.
Mm-hmm. Yeah, and another trick that's useful here is that for ordinal data or nominal data, like here, even though it's pretty much nominal, but you can still order the axis by sorting. And the way to do it is to add sort property in the field definition object, and then by that I mean like the object that you map the channel to, and here we can say sort, and we can say op, and op is the aggregation operation that we can do, and here we want to sort by the count. So here you can sort by op, and here you can see that we now order the axis by the count of number of days. And here's number of days because each item or record in the data set is 1 day. So here, and here you can see, interestingly, actually Seattle has a lot of days that's sunny and not that much raining as many people complain about. Yep. And if you want to reverse the order, you can say order, and you can say descending. You should reverse the order. So by default, it's ascending order. So you can also sort here.
I guess the main point here is that there's a bunch of ways to customize them. More is in the documentation.
Yeah. And sorting is one very useful thing when you analyze data. You want to see that. So if you have like say 20 or even 50 categories and you want to see top 10, sorting is a tool to analyze, right? So another thing. So the last field is date, and date is quite interesting. So date is actually temporal data. So let's reset this and let's see. Yeah, this is not very useful. Why? Because as said, this data set is a daily data from 2012 to 15, and here what this histogram says is we have one each for each day. So what we say at the beginning is pretty much correct. But what's interesting about date here is that we can also apply time unit and only analyze part of the date field. For example, we can say year, and here you can see that maybe I change it to point because this is So you can see that mostly they have equal number of days, maybe except the first one that I think the first one looks taller because it's a leap year.
I think it was a leap year, yeah. 2012.
Yeah, so you can see here that actually, like for number of days in each year, the first one is like a leap year. Yeah, or we can change to month. And this is probably not too surprising in the sense that there are more days in January than in February, but you can do other kind of analysis too. Like instead of counting, you can do average or min or max of other variables, and that's exactly what we're gonna ask you to do next.
Maybe a little bit more context about this time unit. You can think of it as binning, but it's binning according to a slightly more complicated formula where we can automatically extract. We automatically extract the month, the year, the day of the week, and other things. You can even extract multiple things at the same time. But look at the documentation if you're curious about these kinds of things.
Yeah, and before we give you a few exercises to explore this data, another feature I want to show is how to calculate a new field, and basically we have minimum and maximum temperature, and here we want to calculate a range, like what's the range between minimum and maximum. And what we can do is to add this, we can add a new property on the top level called transform, and in this transform property we can do calculate, and within this calculate property is an array, and you can say I want a new field called temp range, and then you can give a formula in expression expr property, and here you can refer to existing data using datum dot. You say temp max minus datum dot temp min, and down here now you can refer to this new field called temp range, and it's quantitative, not temporal, and boom. And here you can see temp range. Maybe I should bin it because there are too many different values. Here I pretty much get the histogram. I change this to bar. Okay, now I get distribution of range of temperature in a day, and you can see that in a rare case the temperature can change by roughly 20 degrees Celsius in a day, which is pretty crazy, but most of the time it's not that bad. Yeah, so this is a way to calculate a new field, and using these features you can try to examine like different questions. Like again, like when you begin, you probably want to examine univariate summary, and with this feature you can ask more specific questions. For example, here, how about you try to create a visualization to answer the following questions? So, and these are a lot of tasks, so I'll give you a few minutes instead of 1 minute. So maybe we'll copy this to the Etherpad.
Doing right now.
And if you have a spec for each question of this, then paste it in the Etherpad, and we can see. And if you make a good one, we'll share with other people, and we might show our attempt to create visualization to answer these questions. So we just add this question to the Etherpad, and you have a good spec for showing an answer to this question. Then
should we show the first one?
Yeah. Okay.
We'll do the first one together, and then please, for the second, third, and fourth one, we'll give you some time, and feel free to ask questions at any time. But yeah, let's do the first one together.
Okay. So average precipitation for different months. Okay. So typically, in some sense, so in analysis, typically you need to distinguish between independent variable and dependent variable. And here, the dependent variable that you want to look at is the average precipitation, and the independent variable or conditioning variable is the month. And we usually want to map the conditioning variable to x. And here, that's what I'm gonna do. Okay, let's remove the transform because we don't need it now. And then I'm gonna map the date, and I want the month, so I set time unit to month, and
parse this for now.
Yeah, it's temporal. So let's parse the intermediate. Okay, that seems right. And then I want average precipitation. So I say mean. Oh, another shortcut is you can either say mean or average. That's the only function that we have to name because it's so common. I use mean for now because it's shorter. Precipitations. So here, now you can see that you see average precipitation per day in different months, and you can see that in May, June, July, August, these are summer months, so not a lot of rain. But in winter, it's pretty bad. More rains in this November and December. So this is how you can create. It depends on if you wanna focus on specific value of the visualization. For example, like bar here, you can read the value easier. But if you want to show a trend, maybe using line is easier. Like here, showing the same data with line, you focus more on the trend. I guess you can see like the trend going down in summer and going up back again in fall into winter. Using line shows trends better, but if you want to show data bars, easier.
For the second one, you want year and month together?
Yeah. So
maybe we should show like month and day of week or something.
Yeah. So one thing that we haven't shown before to answer the second question as a hint is that you can say year, you can say month, you can also say year month. So you see like repeating patterns over the month in different year. So here you see precipitation across 4 years in different months. So you see repeating patterns like summer is going down, in winter is going up. And the next question that you might want to try to answer is like, what's the max temperature for different year and month using this time unit equal to year month. So how about let's take a minute to try to do that, and we can show the answer.
Okay, let's post that on in the Etherpad. This one, with month instead of year month. Month instead of year month for time unit here, because that's the first answer, right?
Oh, okay. Okay, so that's the first answer. You can use that to create.
Okay, we'll give you some time and then just paste your answers when you have them. Perfect.
Okay, so looks like someone come up with an answer. And yeah, that's pretty cool. We'll copy that and use your work. And yeah, here's the answer. So basically,
it's a mean.
Oh yeah, actually yes, good catch, Dominic. So we want the max, like really the max. So it's a little trick question. So what you create here is the mean of the max value, which is pretty close to what we want. But if you want really the max of each month, then the aggregation function that you want here is the max. But yeah. The mean of the max is a valid thing to create too. It depends on what you want. But yeah, that's.
Okay, we ask for the max of the max.
Yeah. Maybe we should be clearer, but yeah, that's pretty close. And
so if you look at this visualization, maybe one thing you might notice is, it looks like the trend here goes. Well, does it go up? Yes or no? And if you want to answer this question, well, the easiest way to answer this is just year. Look at the year, and look at the trend over time, and it looks like not too much difference, but yeah. Okay, let's do. Let's look at the next one. So that's the. Oh, actually, we just did that. Sorry, I just answered the next one. Sorry. Okay, let's ignore this one then.
yeah, but I think what I want to show here actually.
Max?
Yeah, if you want to show the average, which Dominic was a little excited and actually show you the answer, but that's fine. Well, if you actually calculate the mean of the maximum temperature over the year, so like if you look at the max, sometimes you get affected by the outlier a lot. But if you look at the mean, or even better, look at the median, which is less affected by the outlier, you can see that maybe when people talk about global warming, is maybe true. The maximum temperature goes up. Yeah,
let's not jump to too many conclusions here.
Yeah, but maybe true. Who knows? We need more evidence, but maybe that's quite interesting.
Okay, and now the last one is, since we answered that one, is the average temperature range for different months. And I posted the transform that we used earlier to compute the range.
Yeah, so let's take another minute.
You. Looks like you're struggling with the temperature range one. Do you want to post your spec as you have it so far, if somebody has one? Okay, that's one. Copy that one. Might actually work. Right? This looks easy.
It's pretty solid, I think.
Mm-hmm.
Yeah, I think that's the right answer. So basically, you create a new field using transform.calculate and create a field new name temp range and calculate the max minus min, and then you map the range, the mean of the range to y, and then map month of the date to x. Pretty much that's it. Okay, so that's cool. And yeah, here are the answer for the same questions that we asked. And there are a few other features that we want to show you briefly. So one is stacking. So let's start with a histogram. So okay, this is a histogram that we show you earlier, like max temperature, like histogram of max temperature. If you actually add color to it, like if you want color by day that have different weather type, and it's nominal. So if you add color to a bar, we automatically stack it for you. Which is a little different from when you add to point. We never stack point, we just plot them separately. So this is one thing that we automatically do. You can customize the bar not to stack if you want in config. Yeah, it's in config.mark. Just so you know, typically you don't need to do this. Like you can config.mark.stack, and you say none. I think I mistyped it somehow.
I know where you should.
Okay, let me look up the documentation a bit because I might forget it. Oh, I think it's stacked. Yes, that's a typo. Yeah, we are working on adding more linting to the Vega editor. So when you make typo like I just did, it should be not a problem. It should not be a problem. Here, if you don't stack, you might not see much. But if you customize opacity, like to 0.2, you see that yeah, here there are some layers here. If you stack, you hide the stack disable. Even if you turn off the opacity here, you can see that there's no like layer or occlusion. So just so you know that how this is the stack is working. Another thing that's kind of useful to do. So right now you stack, you're creating one chart. You can also split the chart of faceting into small multiples using row channel. Like here, if I change the channel to row, it will split the chart into multiple subchart. And in this visualization, we call this small multiple. So here we can see the distribution of temp max for different type of weather. Like this is the chart for distribution of temp max for sun, for when it's snowing, when it's rain, and when it's fog, when it's drizzle. And you can see here that yeah, usually when it's snow, the temperature is low, and there are not that many days that it's snowing in Seattle. A lot of time it's sunny, a lot of time it's raining, a lot of time it's foggy, and the distribution are quite different. And there are sometimes drizzle, and it's quite interesting that the temperature for drizzle they are quite uniform. So that's another thing. And another useful feature that you can do, the last one that I will show today, is filter. So like calculate, you can also filter, and you can say like if you want to show only the data when the weather is foggy, it's fog. Then I can say filter and say data the weather equal to fog, and this is a JavaScript-like syntax, and we can add 3 equal, but let's say let's add 2. It's the same thing. And if you parse again, this is the histogram of temperature maximum is already foggy. If you compare this, like I showed two visualization here. One is the small multiple of facet plot I showed earlier. It's the same thing as this subplot that I showed here.
Okay, we just had a question on the Etherpad. Can I drive?
Okay.
Okay, so So the question was for this spec here, which is actually quite a cool spec. So let me show you this one. Okay, so in this specification, what is happening? There's a compute to compute the temperature range. Then we have the line chart that we had earlier, where we showed the temperature range for different months. But then, in addition to just showing the temperature range for all years together, this was broken down into different years. So for each year, we see one line. And by default, Vega-Lite created an ordinal color scale here, because there's some inherent order to it. If you don't want that, okay, we'll see. I think what you should do to change that is to change the scale type.
Range. Change range.
To range.
Change the range. The type is also still ordinal.
Oh.
Okay, so here when we use time unit, the scale type it becomes ordinal value, right? But here you can customize the range, which in this case is the color, and this could be an array, like here we try to map it to RAM of green, but if you want to map it to say totally.
Can I provide just a string of the color scale?
Yeah, I'm gonna show that too.
Like
yeah.
a Tableau 20 or whatever.
Yeah. So if you say here, something.
Oh, it used the first and the second one. It interpolates between red and blue.
Oh, that's interesting. You can use this too.
It interpolates between the first two.
Okay, that's
thinks it's an ordinal. Okay, that's a tricky one. Because of time, we automatically treat it as an ordinal here in this case. If you don't want that, I guess you would have to extract the dates, extract the year somehow before you pass it in, and then use an ordinal color scale.
And what's the question?
How do you make it? How do you have different colors? How do you use a rainbow color for this?
Ah, I see. So let's try to use nominal. I don't think it's gonna work. Yeah, it's not gonna work. So that's a good question, and I think we should support it, but we haven't tried it before, and we'll try to fix. Yeah. We'll try to fix it. It shouldn't be a big deal.
Okay.
But it's good that we in our we can do similar things. It's just like we haven't tested this case, and we might have a minor bug here.
Yeah, I think there's just like some wiring up that we have to do, but we'll see it. Yeah. So what's happening is internally there's different color scales that you could use. You could use an ordinal color scale, a normal color scale, or quantitative color scale. But for temporal and time unit, we automatically make it ordinal, and I don't think there's a way to change that right now.
So to explain a bit more about this is that Vega-Lite compile to a lower level representation in Vega, and in Vega we can definitely do what you just asked for, and because we can do that in Vega, we can compile Vega-Lite into that, but we haven't handled this case in Vega-Lite, and that should not take too much time, and we'll definitely handle it.
Yeah, we'll fix it in the coming days.
Thanks for detecting bug for us.
Thanks for detecting the bug. Okay, let's go on continuing tutorial.
Yeah, so we show filter, and there are a lot more examples, and we have the URL here. Like as I show a bit during the break, there are different types that we support, but we cannot cover all of them here. So you can look at the gallery. Like there are different type of plots. Like here, Dominic recently created a GitHub punch card. Like if you have played with GitHub, I did, and this is a spec for it. So basically,
So for a little bit longer. So what's happening here is we're mapping. So we have data about like contributions from people. In this case, it's just fake data, but you could think of like when you're submitting something to GitHub. And we're extracting for the Y here the day of the week. For X, that's the time of the day, so it's hours. And the size is the number or the actually in this case the sum of contributions of counts per day. So we have counts per day, and we sum them up and show that as the size here. Yeah. So here in this case, because in the data we already have counts, we have to do a sum. If you just had individual records, you would do a count.
Yeah, and there are other type of charts. Like here, you can also create stream graph or stack area chart, and like some more example of faceting. So here there are a lot of examples, and you can view the code, and the documentation for all the syntax stuff. You pretty much seen most of it, like data transform, mark, aggregate, bin, sort, time unit, and you can also customize scale and axis, and we show some customization. Like yeah, there are documentation here, and like more example in the doc. You can take more look afterward. Yeah, so that's briefly about how, like, mainly about our Vega-Lite. And now before we go to next part, which you can also use Vega-Lite within Jupyter or IPython if you are not familiar with that. But before that, I mentioned before the break that you can fork my demo, right?
Mm-hmm.
Like there's this to remind you, like there's this repository like vega.github.io/Vega-Lite demo, and you can fork it. And like here, I fork it into my Canadian build/Vega-Lite demo. And the other thing you need to do to make it work for you is kind of
show that it doesn't work first.
Yeah. So
show the URL.
So if you go to like here, it doesn't work because GitHub is a little funny when you fork it, even though you have this branch already. But if you go to index.html and then you edit it a bit, like yeah, maybe I modify the data, or maybe I don't even modify it. I just add a new empty line and commit it. And now if you go to setting and you see that okay, now GitHub knows that I want to publish this to GitHub pages, and I refresh. Now it's working. So yeah, it's just a glitch about GitHub, and it's not really our bug. But you can go to Vega/Vega demo. You can fork that. You can modify the spec and publish your own visualization if you want. So that's the point I want to convey here. And so I'll pass it on to Dominic to do the.
Or do you want to do poll server for a second so we can swap? So I can prepare things. So we. Oh, I guess I'm already in here, right? So you would. How do we do this? Okay. Stop screen sharing here.
Okay, so yeah, we're gonna transfer to another computer to show this part.
So do this.
No.
This button, and then you turn the audio on. Wait, let me turn it off here. And then I do screen share. Okay, so we just switch between two computers. Now you should be able to see my screen and hear me. Is that correct? Is that working? Yep. Okay, perfect. Good. Whoa, Inception. Okay, so what I would like to show you is how you can use Vega-Lite in IPython notebooks or in Jupyter notebooks. And we have this website here, which is linked from the slides, where we developed this little wrapper for Vega-Lite in Jupyter. We have installation instructions here and usage instructions as well. But yeah, all you have to do is on the command line. I'm going to show you now. Okay. Sorry. Okay. Sorry. Never mind about all this. Okay. All you have to do is in your Python environment, install the dependencies, which are just Jupyter, Vega, and Pandas. So we have a pip package Vega, and just install these things, which will take a second. Shouldn't take too long. And then you just install the extension, which is just a little. It's called an NB extension, which is something that Jupyter just implemented in I think 4.2. So it's a relatively recent feature. So you probably need the latest Jupyter for this to work. So you just install this extension, and it all works. We don't actually have to enable it. This is just here for to use it. And then we just start the notebook. Let's create a new notebook. And then in this notebook, all we have to do is just import, load some data set. In this case, I use just Pandas, which is a common data science tool for processing data. So you can also do some of the aggregations that you could do in Vega-Lite. You could already do it in Pandas. And then import the Vega-Lite module and just pass in the spec, and that's all you have to do. But in order for this to work, you need a file. So let me just copy file. Okay. So now I have a the cars data set here, the cars.json data set in the same directory as the notebook. So to load it, oops, sorry. So to load it, I just read it with Pandas. Now I have the data frame here, which is this data set about cars. So you can see it has acceleration, cylinders, displacement, horsepower, and so on. And this nominal variable for the origin here. And so instead of looking at the table here, which is pretty large. Oh, the cars.json. Where did I get that from? Oh, you don't have to follow along, by the way. Sorry, I should have mentioned that. The cars dataset is available from the repository where the IPy tutorial here. Sorry, this one here. So if you go to this IPy Vega under data, there's cars.json here. So I'll just post this link. So it's coming from. But you can also use your own data. I just want to demonstrate it with this cars data set here. So now that we have the Pandas data frame, all we have to do is import Vega-Lite, and then say Vega-Lite.view data frame, and then we pass in the spec. We don't have to provide the data here. It's enough to just pass in the mark and the encoding. The data itself is then is automatically inserted. So all we have to do is run this. and then we get this Vega-Lite visualization here. So this is just a standard visualization here where we map the acceleration to y, the horsepower to x. If we want to modify this, we could also then the to the color, and now we automatically break down this visualization by the color. Or if you want faceting, you could also do it this way. Okay. I don't know why it still shows the color. That's odd. Anyway. Okay, so that's just what I wanted to show you, that we have this this available. You can use it. We're still working on adding some more features here, but the Polestar. Okay. Now you should be able to just switch back.
Yeah, I turned off the audio.
No, you can turn off the. Oh, you can use leave the audio on your computer.
Yeah, we shouldn't turn it on both, otherwise.
Okay. Yeah.
Okay. Yeah, and another note about if you are a Python user is we are collaborating with people in who develop Jupyter to create a more friendly API instead of like using JSON or the dictionary syntax in like we show in IPyVega. Like there'll be a better API coming up soon, but yeah, that's not ready yet. That's why we're not showing it yet. But yeah, if you are a Python user, you probably wanna like watch this repository on GitHub. So another way that you can use Vega-Lite is like, so what we have shown so far today is manually writing JSON spec or manually coding visualization. We actually developed an open source project called Polestar, which is pretty much our lightweight implementation for Tableau style interface for creating visualization. For example, here we get load a dataset, and this is a different dataset about cars. And if you want to create say a dot plot of acceleration of car, then we can drag acceleration to x, and you get a dot plot here. And if you want to create like a scatter plot, you can drag this to y. And under the hood, if you click debug, we are basically creating Vega-Lite visualization under the hood. And we are working on this to make it more feature complete, like having comparable feature to Vega-Lite. But for quick exploration, like creating plots like this, it should be pretty straightforward. Yeah, and you can like change the data and try to load data from URL or pass your own data. So pretty much it's like a wrapper, a UI wrapper that you can create Vega-Lite visualization. Yeah, you can do some transpose or something like that. So that's a quick overview of Polestar.
Maybe if there's some questions, we can answer them.
Yeah.
And can you zoom in?
Yes. Okay. Let me redo it again. Thank you. Sorry. So it was quite small. So on the left side in Polestar here, when you load the data, we show the schema of the data, like cylinder here is categorical, like name here is categorical, year is temporal. This quantitative fields. And here you can drag fields like what I just did, like acceleration to x and y. So you see scatter plot here. If you drag origin to color, then you get scatter. You map the origin to color. You can also map it to size, although it might not be the best design because different origin is not merely ordinal. When you map to size, it should be ordinal. Maybe mapping to shape is better. This is how you can quickly create Vega-Lite visualization in Polestar. And right now, we'll work on it more this summer to make it more feature complete. But you can also copy the output spec from here and publish it on the website or something like that. So that's a quick overview of Polestar. We'll improve it more in the summer. So for Polestar, I forget to put the URL on, but it's Vega github.io/Polestar. And I'll put this on the Etherpad. Polestar. And if you are interested in contributing, you can also go to the repository on this URL.
Yeah, all our code is open source, by the way, under BSD license.
Which means you can use for commercial and non-commercial purpose. Yeah. You can play with it, and the last part that we want to show briefly today is, so what we have shown so far is that Vega-Lite can create like single visualization and small multiple visualization, but it's mostly static. And in the lab, what we are working on right now is supporting it for more variety of graphic and support interaction. Oh, I think, okay, let me turn the server on. Oh, it's 999, it's not 900. Okay. So this is a demo version. It's not released yet, but you can create more type of graphics. Let me see which figure. I think
That's the last one, I think. That's 14.
Yeah. So for example, here, you can use the spec within one page, and here this is like a stock market price of a company.
This is all together.
Yeah, this is all together. But you can also select some part to zoom in and focus. We have some minor glitch in the editor, but yeah, it's not a bug for the Vega-Lite. It's more for the editor, but we'll fix it. But here you can easily create this kind of interaction with just the spec you see on the left side. You can create like this one. I need to make it smaller, but basically this is, if you're familiar with MyBotStock's cross filter. So like MyBotStock create this library that you can like filter different variables and then update the bar chart. And here with the code on the left, you can do pretty much the same thing, and you can see that it's pretty succinct. Yeah. So this is what you can do, and besides that, you might also observe that besides creating just one graphics or create small multiple of the same plot, here is actually different plot. So we also extend Vega-Lite to support composing different visualizations. And we also support layering, like this one, like here. No, not this one. Can you remember if you can?
This is layered.
Oh yeah, this one is layered. That's true.
So it's, yeah, if you zoom in a little bit.
Yeah,
so you can see here in this chart we're layering in aggregate over all the years, which is the kind of the very visible line. And then in the background we show the individual lines for each year, which again is actually the mean for each month, but broken down by year. Yeah, I guess the other one is a little bit cooler. Yeah, this one here. Yeah. So here we're overlaying the temperature curve over the precipitation in one chart. And you can see that the x-axis here is shared, but the y-axis is actually independent.
Yeah.
And so these kinds of things will be possible very soon with Vega-Lite. As you can see, we already have a prototype implementation, but we'll release that to the the stable Vega-Lite in the coming months.
Yeah, hopefully before the end of the year. That's the goal. Yeah, and for other research that we are doing, so besides like Polestar, which is what you can manually create visualization, another tool is called Voyager, which is using Vega-Lite to recommend visualization. For example, like if you get a new dataset, like here the same car dataset, instead of manually creating histogram, we automatically generate univariate summary for you. You can see like histogram of all different variables. You can examine each variable, like here, number of cylinders, most of them are even. You can see different name of the car, and you can see that, oh, for this dataset, there are different type of cars, but the name are not unique. Like the same model may have multiple sub-model or something like that. And like car from different origin, most from A, you can examine different variable. If you are interested in a particular variable, like if you're interested in like horsepower, you can select it. And up here, we still show this variable you select, but down here, we also suggest other variables you might want to look at in association with horsepower. Like here, we show horsepower and cylinder, and you can quickly see relationship or association between cylinders and horsepower, and same for other variables. So with this kind of tool, you can quickly explore data. So this is one tool that you might want to use, but my bigger point is that besides writing Vega-Lite manually, like manually coding this, you can also use Vega-Lite as a tool that you can create, like in Polestar, like using Vega-Lite as a file format for creating tools, or even using Vega-Lite as a way to generate recommendation for visualization, like we do in Voyager. So that's like potential application that you might want to do with Vega-Lite.
All of these are, by the way, on the website. The Vega-Lite. Can you go to the Vega-Lite website?
Vega website, right?
The Vega-Lite.
No, Vega-Lite.
Well, on the usage.
Oh, I see.
Usage, yeah. So we have on the Vega-Lite website, we have the tutorials, but also here a list of applications that use Vega-Lite.
Yeah.
So for example, there's the Altair project, which tries to unify how visualizations are created in Python using actually Vega-Lite. There's the Vega for Jupyter notebooks here. There's also one implementation for Julia and in R.
Yeah.
And then the tools that we described, so Polestar, Voyager, and Lyra, which is for very custom visualization design.
Yeah. So to clarify, like the Vega for Jupyter, this one is the one that we show, and I mentioned briefly mentioned about Altair, but it's not like ready yet, but it's gonna release pretty soon. So we want to keep that in mind.
And if you're building something, let us know. We're also happy to include you here on this list.
Yeah, you can actually edit this file and send us a pull request. Basically.
Yeah. The whole website here is actually on GitHub, so you can always just edit the pages here. Okay, that was the last minutes were just a brief tour of things we're working on.
Yeah. So right now, we actually end faster than we thought. So if you have questions, feel free to ask.
I think now, can you disable the screen sharing?
Okay.
I'll turn the camera on. Okay, can you just... Oh, are you still presenting? Should we just turn the camera on? Let's just do yours. And I...
I think other places can. I don't know which one.
Oh, perfect. Okay. I think yours is the one that's streaming live.
Okay.
So there was just a brief tour of all the tools that you're working on, and I hope you're excited about this as well. There was one question about network visualizations in Vega from Titus.
You can.
I know you wanna visualize spacecraft cuts, but there there are visualizations, but they're mostly built on top of the layout from D3, so the first layout from D3. Vega-Lite right now doesn't support network visualizations. What it does support, though, are matrix diagrams. So if you can, so there you would basically put all the nodes on X and Y and then just visualize whether there is an edge between the two or not.
Yeah.
And you can definitely do that in Vega-Lite.
Yeah. So to clarify, I think. Okay. Let me share the screen. So to clarify, we mostly show Vega-Lite, which is like a lower level, and we show briefly the high level. That in the editor, like if you look at the editor, there are two modes. Like be careful. Today we show Vega-Lite, and there are a lot of examples, and this compile into low-level Vega. And what Tex has asked is, can we do network? And Vega support a few networks, and what Dominic say is the matrix.
Yeah. So you can actually do these matrices in Vega-Lite as well. What I wanted to show earlier in Vega. Sure. Trying to find that one. Where is it? Was it an interactive one? Force drag.
Yeah.
Oh, this one here. So this is just a force layout, but you have to write low-level Vega in order to get this visualization, and it's very similar to what you can do in D3. So here the layout is computed by. Where is it?
Yeah, I don't think we should go into detail today because we haven't teach them what's the components of Vega. So.
Yeah, this is a little bit confusing, but yeah, you can do it in Vega. In Vega-Lite, you would create a matrix visualization. That's possible.
Yeah, but to be fair, like if you want to work on network right now, I would say probably Vega D3 is a better tool. Like Vega-Lite, I don't think we will support network in the near future. In long run, it might happen because it's just like grammar graphic can support network. You can extend Vega-Lite in the same way, but that's not the priority in our roadmap right now.
Maybe if you want to unmute and ask questions, that would make it a little bit easier for us as well.
Where did we get cars.json from?
I already posted those things. Okay.
Okay.
Cool.
And good. Okay.
Oh, the mic is not working?
Oops.
Okay. So I think Titus is just posting that there are not more questions at this point. I know this was a lot. I hope we could give you a sense of what Vega-Lite is about and how succinct the descriptions are or the specifications are that you have to write in order to create visualizations. We hope that you found this useful and can use it in your explorations, or if you want to create figures for a paper, also feel free to use Vega-Lite. If there are any more questions, we're happy to also answer them by email. There's one more. Oh, how to export pics with quality. Haha. Okay. Just one question came up in the Etherpad, which is how to export these visualizations with high quality. So when you create a visualization in the editor, at least, what you get is, if you zoom in here, you can see that it's not that it's just a pixel graphic. So this is just rendered on a canvas. Oh, sorry, I'm not showing my screen. Yep.
You shouldn't even turn it off.
Yeah. Okay. So now I'm sharing my screen again. So I'm just in the editor. I just loaded the first example here. By the way, a lot of the examples that we showed are also in here. So just a simple chart. There's two different renderers for Vega right now. One is Canvas, and the other one is SVG. if you render as a canvas, you get a pixel graphic, a raster graphic. And when you export this graphic, you get a PNG file, which has the resolution of your screen. So in this case, it would be, well, I'm on a MacBook here, so it's a Retina resolution. But on another screen, the resolution might only half of this. So this is not very great for a paper. If you want higher resolution, I would say create it as an SVG, and then you have a vector graphic. And when you export this, you get an SVG, and you can convert that SVG with Inkscape, for example, to a PDF, and then embed it in your paper. If you want to make all of this process a little bit easier, we have command line tools for going from Vega-Lite to Vega, and also then from Vega-Lite to PNG, or from Vega-Lite to SVG directly. So you can use these. We actually use this pipeline to generate all the images that you see here on the website. These are actually SVG images that we show, and these are automatically generated by some command line tools, which you can also use. Okay, so I guess, yeah, export high quality, use SVG, and then go from there to PDF for papers. So this is why these are also pretty high. Well, these are vector graphics, so quite high quality. Okay, so that was good. Okay, so these were the questions. Yeah, again, we're pretty excited to have this tutorial to show you what we've been working on. If there are any questions, let us know. All our code is on GitHub. If you have issues, create issues on GitHub.
Yeah, and we actually have, if you are interested in Vega and Vega-Lite, you can subscribe to a mailing list. Oh, I should paste the link to the, yeah, I'll paste the link to
the Etherpad. So on this mailing list, you can just post questions and get answers from other people that work from us. Posting it in the Etherpad.
Okay, yeah, so if you have questions about that, yeah, you can.
Yeah, okay. Well, thanks a lot for attending, and I think...
Yeah, I hope this is useful. Yeah, it's our first time running workshop in remote, so it's quite an experience. So I hope we are not too confusing.
Yeah. All right, yeah, thanks for attending. It was a lot of fun. And yeah, let us know what you thought about this, and if you have questions. And then we're happy to do it again sometime when we have interactions and everything.
Yeah, yeah.
Okay.
Thank you.
Thank you.
So close the Hangout, I guess.
Okay. Have a good time.